What if I told you that the very thoughts you think about your own limitations might actually be your brain's way of protecting you? That the fears, the hesitations, the moments when you doubt yourself are not just flaws or weaknesses, but signals from a complex system designed to preserve your stability, your identity, even your survival. Neuroscientists are increasingly discovering that the mind is not merely a passive observer of reality, but an adaptive organ constantly negotiating between possibility and risk. This is a theory that rarely gets discussed openly, perhaps because it challenges our most cherished notions of free will, competence, and self-determination. Yet, it may also hold the key to understanding why humans are simultaneously resilient and fragile, why perception can deceive, and why consciousness itself might be more of a network of protective signals than a transparent window into reality. The theory I am about to unfold is not science fiction. It is grounded in neuroscience, psychology, and quantum metaphors that reveal how our brain interprets, distorts, and negotiates with the world. To understand this, we must first recognize that the brain is not a static structure. It is a dynamic, self-organizing system, a network of neurons, synapses, and electrochemical signals that adapts continuously to its environment. When we talk about neuroplasticity, we often frame it in terms of potential, the capacity to learn, to grow, to recover from injury. But there is another side to this plasticity, a shadow function that is less glamorous yet equally essential. The brain not only grows and rewires to acquire new abilities, it also constrains itself to prevent overload, protect identity, and maintain a coherent model of reality. Think of it as a city's electrical grid. New connections can be made to supply more energy, but if too many circuits fire at once, the system risks collapse. Similarly, your mind adapts by sometimes limiting itself, creating boundaries that feel like weakness but are actually protective strategies, encoded by millions of years of evolution. Consider stress, for instance. Stress is often framed negatively, as something to eliminate or overcome. Yet, at its core, stress is an adaptive mechanism. The hypothalamic pituitary adrenal axis, the HPA axis, releases cortisol and other hormones that heighten alertness, focus energy, and prepare the body for action. From an evolutionary perspective, this response increased the likelihood of survival in a dangerous world. But here's the twist. The very stress that feels like a personal burden is actually your brain signaling its awareness of risk in its attempt to regulate energy expenditure. When you feel paralyzed by anxiety or self-doubt, it may not be a flaw, but a highly sophisticated internal calculation designed to prevent you from overextending in ways that could be harmful. This reframing transforms what we perceive as vulnerability into evidence of a highly intelligent system at work, negotiating the boundaries of human capability. Perception plays an equally intriguing role. Our sensory systems do not transmit reality directly. They interpret and reconstruct it based on prior experience, expectation, and biological constraints. Psychologists describe this as predictive coding. The brain generates models of the world and constantly updates them based on incoming sensory data. When something unexpected occurs, the brain experiences prediction error, which it must resolve. This is why optical illusions trick us, why memories are malleable, and why intuition can sometimes feel like a deep truth even when it is a construct. The implication is profound. What you perceive as limitation may in fact be the brain's attempt to reconcile conflicting signals to maintain a functional equilibrium. The mind is less a mirror of the world and more a sophisticated negotiation between incoming data and existing models. Now, let's layer in an evolutionary perspective. Humans have thrived not because they were the strongest or the fastest, but because they were able to anticipate risk and regulate energy in adaptive ways. Fear, hesitation, and even self-doubt are not bugs in the system, they are features. Neurobiologists have observed that the prefrontal cortex, which governs executive function, is intricately connected to the amygdala, the brain's emotional alarm system. This connection allows the brain to modulate impulses, delay action, and assess danger before committing resources. From a biological standpoint, these limitations are life-saving. And yet, in modern society, where physical threats are rare but psychological pressures are constant, these same mechanisms can feel restrictive. The paradox is that the brain's protective strategies evolved for survival, now sometimes conflict with our desire for unlimited performance, creativity, or freedom. Quantum metaphors can further illuminate this concept. Imagine thought as a signal traveling through a vast energy network. Each neuron fires, sending pulses of electricity that ripple through the system, encountering interference, feedback loops, and probability clouds. In quantum mechanics, observation affects outcome. In the brain, attention and expectation shape perception. When you believe you cannot do something, your neural energy pathways may indeed adjust in ways that limit action, not because you are weak, but because your system has recalibrated to avoid potential error or overload. This is analogous to a quantum particle collapsing into a state influenced by the observer. Your mind, in observing its own limitations, may be partially causing them to manifest. It is a self-regulating network, continuously balancing between possibility and protection. Another fascinating layer is the interaction between neuroplasticity and stress resilience. Studies have shown that moderate stress can enhance synaptic growth, memory consolidation, and cognitive flexibility. Conversely, excessive stress can impair function, disrupt networks, and cause cognitive narrowing. The brain seems to exist on a delicate spectrum, optimizing itself within limits that are invisible until they are exceeded. What we interpret as failure, laziness, or weakness may simply be the system signaling its need for recalibration. The adaptive threshold is not fixed. It is context-dependent, shaped by genetic factors, early development, environmental stimuli, and learned behaviors. The question emerges, if your brain is constantly adjusting boundaries to preserve functionality, how do we distinguish between real constraint and protective adaptation? Here's where philosophy and neuroscience converge. Traditional notions of the self often assume a stable core identity, capable of unbounded action if only willpower and discipline are sufficient. Contemporary neuroscience, however, challenges this assumption. The self is not a monolithic entity, but a distributed network, a composite of interacting signals, memories, and expectations. In this framework, limitation is not a flaw but an emergent property of a complex adaptive system. The mind is not designed to conquer all. It is designed to manage energy, predict risk, and maintain coherence across multiple scales of operation. Recognizing this shifts the narrative from personal failure to systemic intelligence. Your perceived weaknesses are not moral deficits, they are echoes of a system finely tuned to survive, learn, and adapt. Consider the phenomenon of learned helplessness. Psychologists have long studied how repeated exposure to uncontrollable stresses can lead to a state where individuals stop attempting to change adverse situations. On the surface, this seems maladaptive, even tragic. Yet from the perspective of system regulation, it may be another example of protective adaptation. If action is likely to produce harm or energy depletion without significant gain, the system may choose inhibition over risk. The brain is constantly solving a high-dimensional optimization problem. How to allocate limited resources across countless demands, ensuring long-term stability. In other words, moments of perceived weakness may actually reflect optimal system strategy in uncertain conditions. This is counterintuitive, yet it aligns with evolutionary logic and contemporary neurobiology. Perception, memory, and attention are all part of this adaptive orchestra. Our attention system acts like a spotlight, focusing energy on signals that matter most for survival or goal attainment. Memory is not a passive recording device, but a predictive engine, reconstructing past events in ways that guide future action. Every thought, every hesitation is part of a network, constantly evaluating probabilities and consequences. In high-stakes scenarios, your brain may temporarily limit your range of action, not because you lack ability, but because the system is simulating outcomes and conserving energy. These mechanisms, invisible and often misunderstood, form the bedrock of human resilience. They are the silent scaffolding that allows humans to navigate complexity without catastrophic failure. Let's not forget the social dimension. Humans evolved in communities where survival depended not only on individual ability but on coordination, cooperation, and risk assessment. Limitation is therefore relational as well as personal. The signals your brain generates fear, doubt, Inhibition are not only protective internally, they also help regulate behavior in social contexts, preventing actions that might destabilize the group. Neuroethics and social neuroscience increasingly reveal that our moral intuitions, empathy, and self-regulation are deeply embedded in these adaptive networks. Limitation in this sense is a social strategy as well as a neural one. It is the brain communicating both internally and externally about risk, energy, and potential consequences. Now comes the twist that makes this theory simultaneously unsettling and enlightening. The moments when you feel most inadequate, when you think, I am weak or I cannot do this, may actually be the moments when your brain is at its most intelligent, most protective, and most adaptive. Vulnerability is a signal, not a deficiency. Hesitation is an algorithm, not a flaw. Self-doubt is a feedback mechanism, not a condemnation. The very limitations that feel constraining may be the clearest evidence of a system working optimally to preserve your integrity, your energy, and your capacity to act when conditions are most favorable. This reframing turns conventional wisdom upside down. What you perceive as weakness may actually be your most powerful ally, a manifestation of neural sophistication that has evolved over millions of years. The implications extend beyond personal psychology into philosophy, ethics, and even quantum metaphors of reality. If consciousness is a network of adaptive signals rather than a direct mirror of reality, then understanding limitation becomes not a matter of striving harder, but of observing the network intelligently. Curiosity, reflection, and strategic engagement with challenges become more valuable than brute force or relentless perseverance. Neuroplasticity offers the promise of expansion, yet the system's inherent conservatism ensures that growth occurs without catastrophic failure. In other words, adaptation is both liberating and constraining, and true intelligence lies in recognizing the balance. So how do we apply this insight in daily life? Start by reinterpreting your reactions, your hesitations, your fears. Instead of resisting them, observe them as intelligent signals from a sophisticated network. Ask questions like, what is this limitation trying to preserve? Where might my energy be best allocated? How can I engage with challenge without triggering protective shutdown? This approach does not promise effortless success, nor does it glorify struggle for its own sake. It invites a deeper engagement with the nature of the mind, a recognition that intelligence is distributed across the system, and that resilience often manifests as self-imposed boundaries. By cultivating awareness of these signals, we can work with the brain rather than against it, enhancing learning, creativity, and emotional equilibrium in ways that brute willpower alone cannot achieve. In closing, the theory that scientists seldom speak of is both simple and profound. The limitations you perceive, the doubts you experience, and the moments of hesitation are not weaknesses. They are evidence of a brain that is actively negotiating risk, preserving energy, and maintaining systemic integrity. These adaptive constraints reveal the mind's incredible intelligence, a sophistication that allows humans to survive, grow, and navigate complexity. They remind us that consciousness is not an all-powerful agent, but a distributed, self-regulating network, continually balancing possibility and protection. By recognizing and honoring this, we gain not only insight into our own psychology, but also a philosophical lens on the human condition, that resilience often masquerades as limitation, and that intelligence is inseparable from adaptation. As you reflect on this, consider, are the obstacles in your life truly barriers, or are they messages from your own nervous system, guiding you towards sustainable action and energy alignment? Can embracing your perceived limitations lead to a form of mastery that brute effort could never achieve? These are questions that have no single answer, yet they are central to understanding the mind, the self, and the profound intelligence inherent in human adaptation. If this exploration sparked curiosity, challenged assumptions, or offered a new perspective on your own experience, share your thoughts in the comments below. Like this video if it expanded your understanding of the mind, and subscribe to MindSpark Science to continue exploring the intersections of neuroscience, psychology, quantum thinking, and philosophy. Together we can navigate the unseen architecture of thought, the hidden intelligence of limitation, and the astonishing adaptability of the human brain.